Every great bridge begins long before the first piece of steel arrives. Before construction, engineers must understand every meter of the crossing.
Okay, zoom in on the main channel crossing point, right here. The depth profile looks stable for the pylons.
This ridge formation confirms the seismic data from the previous pass. And the sediment layers look stable enough for the initial bore.
We are clear for ascent.
Confirmed, all systems green. Proceed.
Ensure the coordinates are precise on that label. Copy that. Confirming the depth now.
The compressive strength on this layer is significantly higher than the previous sample. Yes, the readout confirms it. Look at the density here.
Here's the yield point. Start recording the fracture data. Got it. The maximum load achieved was 300 kilonewtons.
The wind shear is increasing rapidly. Look at the vane turning. Noted, it's shifting northeast, right where the next tower goes. The seismic data confirms the bedrock stability at this tower site. The bathymetry also supports the foundation design perfectly.
With the unknown mapped, construction can finally begin.
Bring the next load forward slowly. Watch the staging area perimeter. Over.
Every future delivery depends on roads strong enough to carry extreme loads.
Charlie B, expedite those pallets to the temporary dock. We have a vessel waiting. Affirmative, ETA 5 minutes.
Tug 2, push the bow out now. Clear the channel for departure. We have incoming traffic.
How's that look? Keep coming down, easy now.
We need to optimize the flow here before the next shipment arrives.
Agreed. The crane movements are currently bottlenecking the process.
All right, team, easy now. Take it up 20 feet.
20 feet, understood. Watching the clearance on the west side?
Roger that. Keep it steady.
We are approaching the foundation site. Check the forward rigs again.
The thermal cameras show some stress on the port side cables.
All right, team, focus on the seismic data near the foundation. We have vessels approaching the exclusion zone. Confirm all schedules are updated. Begin descent sequence. Confirming alignment marker locked. Roger. Descent active. Maintaining pressure. We are showing unstable pressure at the 90-meter mark. Increase bentonite flow to target levels. Roger that. Flow rate adjusted. Pressure stabilizing now.
The density readings are stable.
Confirmed. 45 meters is approved.
We are approaching target depth on Foundation C. Prepare for pressure test.
Copy. Running diagnostics now.
Precision at this depth defines the safety of generations. steel frameworks prepare the ocean floor for permanent strength.
The geometric alignment is confirmed across the corridor.
Data matches the drone telemetry. We are good to proceed.
Lower it slowly, watch the alignment. Copy that, coming down now. The pressure is stabilized, we are green across the board. All right, commence the first surge immediately.
All pumps synchronize on the next cycle. Maintain pressure at 50 psi.
Roger that, 50 psi.
We are approaching the 12-meter mark. Slow the flow.
Roger. Reducing pump speed now.
Moving past section 3, algae coverage is heavy.
Copy that. Check the joint connection point.
Look at that, millimeter perfect across the board.
Absolutely solid. We are good to proceed with the superstructure.
The alignment looks good on the tablet.
Yes, the barge is right on schedule for the first segment lift.
Maintain synchronization. We are approaching the next segment.
Acknowledged. Flow rate is stable. Proceeding as planned.
The pressure wave is exceeding the threshold at Pillar 4. Rerouting support structure analysis now. The new schematic shows the necessary bracing for the tidal surge.
Even a fraction of error can shift an entire bridge. Every cable will one day pull against these points with unimaginable force.
Before reality arrives, every force is already understood.
The laser level confirms the grade. We are within tolerance. Excellent. Let's sign off on the report.
Clear the deck on the barge. We are beginning the lift sequence now. Roger that. Tower segment 1 is secure. Wind speed holding steady.
Confirming stabilization at -5 meters.
Copy. Adjusting starboard crane, 2 degrees to port.
That connection joint needs reinforcement immediately. Confirming the specification now.
Wind forces reaching peak levels. The structure is holding steady at 9,000 pascals. No critical stress detected.
We have the load secured, ready for lift.
Acknowledged. Clear path to the south tower.
Wind gusting, hold position.
System compensating, angle looks good. Ready for final descent.
Almost there. Hold steady. We have alignment.
Confirmed alignment.
Lock it in.
Check tension level on the main spool.
Levels are stable. Proceeding with synchronization.
Tension is holding steady at 45,000. Confirmed. Recording the data now.
Units commence synchronized lift on segment 4.
Copy that. Lifting now. Tension steady.
Slow descent, check alignment on the far side.
Confirmed. Alignment holding steady. We have contact.
Secure the clamps, segment is stable. Bring it down slow, 5 meters to contact.
Copy that, 5 meters.
Clear on the east side.
We need more tension on line 3. The wind is picking up. Hold it there. Bring it down 50. 50, understood. Watch your hands. Clear on this side.
We have alignment. Millimeter perfect. Confirmed. Lock it down.
Wind is pushing the segment, adjust trajectory slightly left.
Confirmed. Lowering slowly. Clearance looks good.
Readings are spiking at the midspan.
Confirmed. Alert on Section 4. Initiating safety protocol.
All right, bring it back easy. Watch the cables on the left.
All right, team, the next section starts just past that cable anchor. Let's move.
The oscillation pattern on the B-span matches the simulation perfectly.
Confirmed. The low-frequency hum is consistent with the wave travel time.
The structural sensors are showing green across the main supports.
All right, let's have the drone focus on that final inspection zone now.
It's done. The certification is complete. Excellent work, Doctor. It looks magnificent.
Tables look good from here.
And the scanners show no anomalies. The trucks are approaching.
Alert. Emergency system test commencing.
Checkpoint 4 reading steady. How is the mid-span deflection looking?
Deflection is within tolerance, no anomalies detected.
Make sure the camera is aligned for the ribbon cutting.
Roger that. Everything is set on this end.
And this is how one of the world's greatest bridges is built from nothing into reality.